Hi everyone, this is Maverick Paul, the chemistry guru. Now in this week's video, we want to discuss how to calculate the enthalpy change of the reaction between sodium and water. Now we have the information given here. Sodium reacts with water to form sodium hydroxide and hydrogen. Balance equation is given and we want to determine enthalpy change for this reaction between sodium and water to give me sodium hydroxide plus hydrogen gas. What information is needed in order to calculate the standard enthalpy change of this reaction? We are given 4 options. Option number 1, enthalpy change of combustion of hydrogen. Option number 2, enthalpy change of combustion for water. Number 3, enthalpy change of formation for sodium hydroxide. Number 4, enthalpy change of combustion for sodium. So we want to consider which one of them are required. And we have 4 options A, B, C, D. Now the topic tested in this question obviously will be under energetics. Based on each of these enthalpy change term, we need to know what it represents and write out an equation involving each of these processes, combustion of hydrogen, combustion of water, and so on. Because if we are not able to write out an equation that is describing the enthalpy change, then we will not be able to draw energy cycle, because energy cycle is effectively a combination of 3 or more of these enthalpy change terms. So let us run through each of these terms and write down the balance equation that represents the enthalpy change for each of these processes. Now, the 4 processes are actually here. Enthalpy change for combustion involving hydrogen. Now, remember, combustion for hydrogen will be burning 1 mole of hydrogen in excess oxygen to give me product, water in the liquid state. So, I need to fix the coefficient for hydrogen to be coefficient 1. Then I balance the rest of the term. So the balance equation that represents enthalpy change of combustion for hydrogen will be H2 plus half O2, both of them in gaseous state, to give me water, 1 mole of water in the liquid state. So this is combustion for hydrogen. Now how about combustion for water? Now if you think about it, can we burn water or can we oxidize water? Because combustion ultimately is the reaction with oxygen, and there will be an increase in oxidation state for the species that undergoes combustion. So if you consider water, where the oxidation state for hydrogen is already a +1 oxidation state, are you able to oxidize hydrogen even further to a +2 or +3 oxidation state? You realize that it's actually not possible for me to do that, because oxidation state for hydrogen, if it is a +1, it will mean that the hydrogen would have already lost its 1 electron. Hydrogen only has 1 electron, correct? So it is not possible for hydrogen to have a +2 oxidation state or +3 oxidation state, because hydrogen doesn't have so many electrons to lose. It only has 1 electron. The maximum oxidation state for hydrogen will only be a +1. So in this case, involving combustion for water, actually there's no such reaction, or the oxidation state for hydrogen in water is already the highest oxidation state. I'm not able to oxidize this even further. So basically the enthalpy change for combustion for water will just be not applicable. We are going to ignore this process number 2. Now, number 3, involving enthalpy change of formation for sodium hydroxide equals formation of a compound will be forming 1 mole of my compound from its constituent elements under standard condition. So what I will do is, I know that sodium hydroxide equals will be the product, the reactant will be the elements in the standard state, sodium solid, oxygen gas, and hydrogen gas. Then I need to fix the coefficient for sodium hydroxide to be coefficient 1, because formation is with respect to per mole of compound that you're forming. Fix sodium hydroxide as coefficient 1. You balance the equation, it will be something like this: 1 sodium plus half O2 plus half hydrogen to give me 1 mole of sodium hydroxide aqueous. That is for number 3. Finally, number 4, combustion for sodium solid will be burning sodium in oxygen to give me product, which is sodium oxide, Na2O, in a solid state. Now, remember, enthalpy change of combustion is burning 1 mole of the substance in oxygen to give me whatever product. So what I'll need to do is I'll need to fix the coefficient for sodium to be coefficient 1. Then I balance the rest of the equation, 1 sodium plus 1/4 O2 to give me half Na2O. So this is the equation that represents enthalpy change of combustion for sodium. So once we are familiar with all these terms, then what we can do is we can try to put everything together to try to draw an energy cycle involving this reaction, 2 sodium plus 2 water to give me 2 sodium hydroxide and H2 gas. Basically what we will do is we will just find terms that are common, then we can try to link them together. So let's say, for instance, I noticed that I will have sodium hydroxide aqueous, and sodium hydroxide aqueous, we actually have formation of sodium hydroxide here involving process number 3. So what I can do is I can link enthalpy change of formation for sodium hydroxide to this term here, and here will be my elements in the standard state. So I'll put my elements, sodium solid, and O2 gas, and hydrogen gas. I know that this portion at the bottom will be my elements in the standard state, and this process will be related to enthalpy change of formation. The next thing we have to do is we have to balance the equation. I have 2 sodium here, so I need 2 sodium element. I will have 2 oxygen in the product, so I need 1 mole of O2 here, and you notice what I have is I have a total of 4 hydrogen in the product, so I'll need 2 H2 gas. So the balance equation will be here, 2 sodium plus O2 plus 2 H2 to give me 2 sodium hydroxide aqueous. I know that this is related to enthalpy change of formation, and I can also consider how do I modify the enthalpy change of formation term, because enthalpy change of formation is with respect to per mole of the compound that you're forming. In this case, I am forming 2 moles of sodium hydroxide. What I need to do is I need to double the enthalpy change of formation. For this question, actually, it's not really required because we only need to know which processes are involved to determine the enthalpy change for this process. So therefore, we don't really need to take the coefficient into consideration. But since we are running through this exercise, I think it is good to recap this idea where we draw the energy cycle. How do I modify the coefficient involving each of these enthalpy change terms? Enthalpy change of formation is with respect to per mole of the compound that we're forming. So the coefficient for enthalpy change of formation will also follow the coefficient for my compound. If I'm forming 2 compounds, then this will be enthalpy change of formation times 2. Effectively, I'm forming 2 moles of sodium hydroxide. Alright, so you notice enthalpy change of formation for sodium hydroxide is required. Then this is related to process number 3. So later, process number 3 will be part of my answer here. Now the next thing we have to do is I have to consider, okay, so I have my elements in the standard state already. How do I link this to this portion here on my left hand side? 2 sodium plus 2 water in the liquid state. Of course, what we can do is we can look out for the rest of the processes. We've made use of equation number 3. Equation number 2 is a total rubbish, right? We know that it is not relevant. There's no such thing as combustion for water, so we can ignore this guy. And if I consider equation number 1, which is combustion of hydrogen, the reactant is elements, hydrogen plus O2 to give me water, and I can actually make use of this here involving equation number 1. Equation number 4 for combustion for sodium to give me sodium oxide is not relevant here because inside this process you notice there's no sodium oxide. So therefore there's no need for me to consider number 4, I only need to consider number 1. Combustion for hydrogen, I'll have my elements here, H2 plus O2, which is here, right? This is my elements, and my product will be water, and my products will be here. So I can link this here, and I know that this is related to enthalpy change of combustion of H2. Then again, we have to consider how do I modify the coefficient for combustion. Combustion is with respect to per mole of the substance that you're burning. So if I am burning 2 moles of hydrogen, then this will be enthalpy change of combustion for hydrogen times 2. And we know that this is related to process number 1. So basically, we already have the energy cycle. Then if we want to, we can apply Hess's law and we can try to write out the relationship involving these 3 enthalpy change terms, involving enthalpy change of reaction number 1 and the combustion of hydrogen as well as the formation of sodium hydroxide aqueous. So now we have drawn the energy cycle, we can answer this question. Which of these processes will be required for me to determine enthalpy change for reaction number 1? I know that I need process number 1 and number 3. Number 2 is not relevant. And number 4 is also not relevant, so the answer to this question will be option B. Alright, so that was the discussion involving this question, determining the enthalpy change of reaction between sodium and water. So if you have learned something useful from this video, please give me a thumbs up, like this video, and subscribe to my YouTube channel for more weekly video lessons. That's all for now. I'll see you next week.